Hello everyone! Today I'm going to be showing you how I went from this to this. You'll be able to see some of my thought process too. But first, a little info about the power armor itself. Since I seem to be the furthest along with power armor, I get to make up all the terms. I call it a Madox configuration because, like the OVA, the pilot's arms are actually inside of the mech arms. And not because my initial design was kind of going off the Madox. I had handles on the mech arms that would control the arm motors with double pull, double throw switches, but they tended to stick a bit, and the tendency to drift away while prevented the armor from running away with me. It made me feel kind of uncomfortable. It should be noted that although the arms are powered, the legs are passive, which means it just uses bungees and springs to support the weight. So that makes it a hybrid, active/passive power armor suit. For inspiration to figure out how to get more articulation out of my power armor's arms, I turned to some retro anime. Bubblegum Crisis has some pretty nifty mech designs by Shinji Aramaki, who worked on Madox, Halo Legends, and other stuff too. Bubblegum Crisis is some wonderful, cheesy 80s cyberpunk noir, so it's a fun ride. Now what caught my attention was the police power armor in one of the episodes. I wondered to myself, where's the pilot putting his arms? Apparently not up in the shoulder pylons along the sides, that would be uncomfortable. With this clip right here, looks like the pilot's arms are down at his side. So, on the outside of the suit, that would be those goofy looking pods on either side of the torso there. But I wasn't gonna just stick the controller in the chest, oh no. I wanted it to operate a lot smoother. Using momentary double pull, double throw switches do make it a lot easier to, build the power armor. I can pick them up in a hardware store, but because I was using 3D printed parts, that means they stick and rub up and sometimes don't trigger when I want them to. So they're going bye-bye. Now, it would be nice if I could use a push button to make a motor go back and forth. Have your arm sandwiched either between two buttons or have it integrated into a joystick somehow. So, how? Double pull, double throw relays, that's how. They're just like a double pull, double throw switch with two exceptions. One, instead of physically moving a piece, you just run current through two extra pins. And two, there's actually no off setting, so it's either triggered one way or the other. So here's how it works. One button just completes the circuit through the relay, which makes a motor turn one way. And the other button both completes the circuit through the relay and sets off the relay coil, which reverses a polarity, making the motor turn the other way. And that diode right there makes sure that only one button both triggers the relay coil and completes the circuit through the relay. So let's get building. Gonna have to strip a bunch of bits of wire, and it might be a good idea to color code them, positive and negative, just so you don't get confused. And I always strip the ends of the wires ahead of time, that way, it's more convenient. And crimping on some O connectors, that way it's easier to attach to the relay socket. And you can see the motor output wires are being attached kind of crisscross fashion. So you can look at it like the first output has the regular polarity that the motor is accustomed to, and then the second output actually has the opposite polarity. But it's okay to reverse polarity on motors because reversing the polarity is just how you make a motor go the other way. You might see my cat interrupting me occasionally. Sometimes he likes to run away with pieces. No, Carl, the part is mine, you can't have it. Both the relay input ground and the relay coil ground are attached together because, well, they both go to the same place. Now we connect two wires onto a diode. The unstriped end of the diode goes to the relay coil, and the striped end of the diode goes to, well, the only available input. So to test it out, we'll connect the motor to the two outputs. We'll connect the relay ground to a battery's ground. Whoops, I almost forgot to put in the relay. So now when you put a positive signal on either side of the diode, The motor will actually go one way or the other. I think the technical term for this would be a mechanical H-bridge motor driver, but I'm not too sure. To make it more convenient, I added on some disconnects. And then I did the same more times. Now see, I was smart enough that before I even started making this video, I checked to see if such a thing was actually possible, so I've already done the right arm. The footage you're gonna see is the overhaul process for the left arm. So I'm just gonna yank the old arm off there, and take apart the old shoulder mechanism, reusing the motors in the new shoulder, which I tested off the suit just to make sure that it worked like I wanted it to. And I attached the new mechanism to the torso using the same mounting holes I used for the old one. And the same with the arm, I just put it on using the same holes. Now I did put on some paper armor templates and toy robot hands I got from a Hobby Lobby. I'll talk about that a little later in the video. I kinda lied and did try the switch controller inside the chest, but it was a big mess of spaghetti.
Somebody touch my spaghetti!
The new controller though has substantially less
Spaghetti!
just a box with a bunch of buttons inside. Each button is linked with the one opposite of it, so it makes the motors go back and forth. Of course that's too small for someone to put their arm or their hand in there. That's why the pilot uses a joystick instead. And let's just put it together so you know what it kinda looks like. Here are the two different controllers, side by side. By moving some of the control mechanism outside of the controller itself, it makes it a lot more streamlined. Now unfortunately, since the controller isn't actually in the limb and is in the chest, that does mean that I don't get a lot of feedback from the arm. But I do get increased mobility, so it's a bit of a trade-off. Now I initially put the relays and their mounting rail in the shoulders, but they seemed kind of exposed. So eventually I put them on the back door, and covered up the wires with plastic conduit protector type thingies. Now I don't have any footage of me putting the relays onto the back mounting rail, but I do have some of me putting them on the shoulder mounting rail, so it's pretty much the same idea. And now I put on the connectors for the motors so they can connect to their relays. Then put the joystick module onto the chest mount. And then connect all the connectors up and cross my fingers everything's wired properly. Which, oddly enough, it was. It's almost like I know what I'm doing. Now something a lot of robot makers don't realize is that when you walk, you do bend your toes. So I made some toes out of wood, and since I'm attaching them to the feet with only one bolt on each side, that acts like a hinge so they do bend. Although sometimes you gotta persuade the bolts to get in there using what my grandfather used to call his computer fixer. Of course, you do have 2 feet, so I gotta put toes on the right foot too. Now, if you watch my channel, you've probably seen some of the tests of the power armor and know what it looks like. But just in case you didn't, it's a prototype suit from Halo Legends. I'm also working on putting in an actual HUD for the helmet, but that'll be for a later video. So how does one make some metal parts? Well, first you need a 3D model. For this example, I'm going to be using the helmet. Then you, quote, unfold the 3D model using pepakura, which is Japanese for papercraft. Print out the parts. Cut out the parts. Make a mock-up out of cardstock, that way you know it's a correct size. Trace the parts onto paper. Cut out the parts. Tape the parts together. Rivet the parts. And repeat till it's all done. I'll be doing a more in-depth explanation when I integrate the HUD in a separate video. When you bolt on parts, you want to make sure you've got washers smooshing both sides of the metal piece. That way there's more surface area to attach to, and it's less likely to rip off. Now everything's all set, we're gonna try walking. Pretty good for my first time walking. At least I didn't fall over. It's hard to see, but the power armor's actually clamping a little too tightly on my rib cage. Taken me about 2 weeks to recover from the soreness and shortness of breath. I entirely rebuilt the shoulders to fix that problem, so it's now a little wider on the inside, but that's an unnecessary fiddly little detail that, unless you made the suit, you wouldn't really notice. And the back of the suit is pretty naked at the moment. This was before I put the relays onto the back. It's about 10 degrees above 0 Fahrenheit in that garage. Plus it's late at night, so I'm kind of tired in the footage. Unfortunately though, when I do get out of the power armor, it can't hold itself up. To fix that, I'm going to be putting in some cables that tighten up the joints when the door opens. That way the joints don't move when I get out. But that's for another time.